the answers to get you the right answer.
Yeah.
Sorry, I'm using the word answer too many times, but you get the idea here. So what you do here is you go through and say, hey, can I get a GCF? Well, I'm going to check and see if, is 444 divided by 42?
No.
No. Yes?
No.
It's
No.
6. Is 240 divisible by 42?
No.
It's 6.
No, it cannot.
24.
It's not 42.
So the GCF is 6.
Yeah.
Yes. That's it. Plus 40.
Wait, I thought it was 7.
Wait, 24?
It's 24. That's right.
Whoa.
It's 74.
74.
Okay, something's a little screwball-y there. All right.
I think you're done. No, you're not.
What times what is 280? You got to get a negative for it. In other words, I don't want to do that problem.
Yeah.
So what could you do to figure out if you have an integer value 0?
I don't know.
Plug it in.
Use y equals. So what I'm going to do, if I go right to my y equals, and all I'm going to type in is what's in parentheses because I've taken out the scalar. So who cares about the scalar? So we'll type in, but we never learned. Yeah, right. All right. Now 7x squared, was it minus, help me?
74.
74?
Hey.
Plus
X. Yeah, same thing.
40?
Yeah.
Okay. So what I'm going to do is go right to my table and just quickly glance through to see if I'm going to get a value of 0 somewhere.
40.
Well, that's 0 comma 40, so it's not 0 in the y column. But if I go to 10, I know 10 works. So therefore, I know that 10 is a 0. So what I'm doing here is I'm not going to try to figure out what times what's 280 to add together to get something else. I'm going to use synthetic and use a 10 because that's my 0.
Cheat codes.
That's what these are.
These are cheat codes.
So if 10 is a 0, the term becomes, you have 6, then you have x minus 10, and what are you left with? 7x minus 4. Go to the next problem. You're right, it's the cheat code, ABBA. ABBA. You just keep pressing that button, you can play Contra all day long. No, not Contra. Contra was up, down, left, right, start, stop, select, or something like that.
How do you?
ABBA was for Akari Warriors. Akari Warriors was a great game on Nintendo. It was one of the first, like, you know how they used to have the scroll through screen as it just kept scrolling down towards you? Akari Warriors, you're just a guy with a gun, you just run around, you just kept, if you died, you press ABBA real quick and you come back to life and you keep playing. Awesome. Contra was start, select, up, down, left, something like that. If I had the controller in my hand, I could do it. Discriminate, remember, what number is that? Discriminate real quick to recall.
Oh, I got this.
In order to work with a discriminant,
It tells the nature of the.
set aside equal to 0, and you're just pulling out the b squared minus 4ac. So I have 9x squared plus 6x plus 7. By moving it equal to 0. B squared minus 4ac is my discriminant. So it's going to be 36 minus 4 times 9 times 7. Just by looking at that, I know it's going to be negative. Because 9 times 4 is 36, times another 7 it'd be even less than that. So I know this is going to be a negative number. If I have a negative discriminant, how many solutions and what type are there? They're 2 imaginary. How do you remember that? Well, if the discriminant is positive, you have 2 real. If it equals 0, you have 1 real. And if it's less than 0, great movie, by the way, it's 2 imaginary. Less than 0 is a movie. 1980s. 7, yeah. Yes, sir.
So, following this, why wouldn't you use the negative 6?
I did.
Never mind.
Yeah, and I was talking with Will earlier today. One of the things when you're working with discriminants and you're working with quadratic formula and whatnot, it's always better to deal with your leading term coefficient to be a positive. Okay. What number was it that you wanted to look at that was a negative? That you switched it around? It was 1, yeah. Like on number 20 real quick. Same idea. It says use the quadratic formula.
Opposite of B.
So you got to get everything, move everything to the left because this is positive. Now here's the thing. Am I going to be looking over your shoulder going, you're out of here? Am I going to do that?
I feel like you would.
That'd be awesome. So here's the thing. If you forgot the quadratic formula, what could you do real quick to see if you have an integer value?
Plug it in.
Sing it.
If I start singing it, there's no final.
I like it.
Opposite of B.
So if I do this, let's say if I go to my tables, maybe I might get a 0 somewhere. I don't know. Oh, -5. Sometimes it'll work, sometimes it won't. If you don't see a 0 and the graph crosses the x-axis, then you'll have to go through and find the actual root ones. But in this case, we got lucky and I knew I have a 0 at -5. So if I do this real quick, I get that. So I have 0 or terms of x plus 5 and 2x minus 19, which gives me zeros at -5 and 19 over 2. So let's say I forgot the quadratic formula, could I still get my results?
Yeah, you could.
Oh, it's mine.
Because it's minus.
Yeah.
Now here's the other thing. If it says find the zeros and you have a list of them to go through, couldn't you just substitute in and see which ones work if you forgot how to math?
You forgot.
I forget how to math.
I mean, I'm going out on a limb here. I'm just saying.
I'm going on like.
How far on this?
These tips are so useful.
And you probably never would have thought of that. You're probably sitting there thinking, like, oh my God, I got to do all this work. Like yesterday, we were working with
Honestly, I
comics.
probably would have picked a random answer.
Yeah, but don't. You guys have so much time to take this test that don't overwhelm yourself. I'm not lying. You'd be surprised that I like the idea what you're saying, those cheat codes. A lot of this stuff is like a little bit of a cheat code because I didn't let you use the calculator a lot. So let's use it a little bit. Caitlin, I'll go right down the line here. What do you got?
Well, you want to about like I showed you the answer was -5.
Yes.
But then you said like exactly the negative so first, and that's but then
I know.
did that like you got
Did I write it down with the wrong sign someplace? Probably. Because that's the right answer. I don't know what because if you go through the long form with quadratic, then let's see, we get opposite of b, 9 plus or minus the square root. B squared is 81 minus 4 times a times c all over 2a. Was it, did I write down the wrong sign?
Don't worry about it.
This one is Michael.
2A.
Are you sure?
100%.
And then it goes
Wrong.
Sir,
Oh no.
Want to do this real quick?
which one?
36 to 30 here.
Every time I raise my hand, it's too late.
Yeah, I got that.
Oh, I did that. What? 36 through.
Oh, we did these.
I don't know.
Oh yeah, I need this stuff.
For real. I tried it, it did not work out. It's just so boring. Well, we did
All right, so at 36, you have zeros at -3, 1, and I. Therefore, you have another one at negative I. So
-5.
what is the term that creates plus or minus I?
X squared plus
X.
1.
X plus X squared plus 1. Yeah, okay, sorry.
That's, what?
My other two terms are going to be x plus 3, x minus 1, and I just multiply it all out.
That's it?
Yeah.
Wait,
Yeah.
how do you know that?
X squared plus 1.
Now, when we got to these things here with the fractions, remember, there's two different scenarios you could come across.
Do one of them like x minus
If it was
and then
negative 3/5 as your 0, that means your term could have been x plus 3/5, or your term could have been 5x plus 3. Subtract 5, or excuse me, subtract 3 divided by 5 to get your 0. The way that we were able to decipher which one they wanted was to look at the list of the possible answers. If they wanted just x plus 3/5, if you multiplied that all out with all the fractions, your leading term would have been 1. If it wasn't, if it wanted the other one, your leading term coefficient would not have been 1. And that meant you'd have to do that 5x plus 3. Does that make a little bit of sense? Same deal with 38. When it says you have negative 3/2 multiplicity of 2, that means it's there twice. So it's 2x plus 3 quantity squared, and then an x minus 2. Or depending upon what the solutions give you, it could have been x plus 3/2. You just have to look at what their multiple choices are. Does that make sense?
yeah.
All right. Yes, sir. Overture, hit the lights. Distribute. Negative 6 root 3 minus 6 root 18. Simplifying the square root of 18 gives me a 3 root 2. So I have negative 6 root 3 minus 18 root 2.
Sweet.
Give me 1 second, I'll get you next. We don't worry about absolute value. We didn't deal with the absolute value. I'm not worried about that. So if you won't see absolute value on the final, don't worry. There are some rules that we just don't concern ourselves with. 4 through to 32.
Or wait, hold on.
Oh, is it another thing we did on the
The
test?
4 through to 32.
That's 2, but it's a
No.
Oh my.
5th through to 32 is 2.
Is it? After doing the test type?
All right, let's do this. So you have negative 2. Perfect. 4 through to 32. Well, it's the 5th root of 32.
Yeah.
So you have to leave them in. I can't simplify the 4th root. I don't believe we can. There's no, because the next 4th. I mean, if I go 3 to the 4th is 81. That's not going to work. Okay.
So you just
Yeah. And that's the tricker on this one. They're going to make you think, oh, 4 through 32, that's 2. And you're going to take 2 out, you're going to get negative 4, and you're going to go through there. So if we do this, we should get 32 on the inside. 4 goes into 6 how many times? Once. 1 comes out, or instead of 4 comes out, 2 stay in. And then the cube. And I think that's what they should have said. They took a 2 out of that? Because
Shouldn't it be P and then Q?
oh, I know what they did. All right, here's what they did. I didn't think of doing it this way. I don't think we did one like that. This is 2 to the 5th.
Can we
That's 2 to the 5th, right?
I guess.
4 goes to the 5 how many times? 1 can come out and then 1 stays in. So that's what they did. I don't think we ever set one up like that, did we?
We need to talk about that.
Don't like that one bit.
4 goes into 6 how many times? So we had the 1 came out and we had 2 still in. P stays and Q stays, I believe, right? That's what it should look like. I didn't even think of doing it that way. I also had a headache, so that happens.
Oh, 11. because I did it and it like makes sense, but then like at the same time.
Subtract 8, divide by 5.
Yeah, but then it's like anything like.
Got it.
Can you do number 4 because I did it and I didn't get any of
Use
this.
your calculator.
I did.
On 4, remember on 4, you can't, what happens is you can't put the whole thing into the calculator,
I didn't know that.
but what you can do is multiply the conjugates in the calculator. You'd have to do them independently. So what I would do is you'd have 7 minus 7i over 10 plus 4i. Do you agree that you have to multiply top and bottom by 10 minus 4i?
Yeah.
Okay.
Make it. I don't know how you find like.
So what you do is you type this part in the calculator, just separately. So you have parentheses 10 plus 4i parentheses 10 minus
Second decimal.
4, yeah, second decimal, and hit enter, and that gives you your denominator.
Can we just like, say
116.
squared?
I was trying to do it by hand.
No,
Confusing
so I'll let you use your calculator. So, and then if you do the top part, you'll see what happens. Then you get 10 minus 4i, 7 minus 7i. Move this. 42 minus 98i. And then from there, just start simplifying out the fractions. I would start with, it looks like, I think 6 might work. No, 6 won't work. 4 work?
Is answer B because it looks like.
I'm pretty sure
It
it's
just
B.
looks like.
It might just be 2s then.
It's B.
Yeah, so it would be B. Make sense, Lisa?
Yeah.
Yeah, whenever you see something like that, don't try and crank it all out by hand. Just use the buttons on the calculator.
I like that.
This is why I didn't give you guys these types of questions with the calculator. Sir.
On number 9, is there a way like
If you know your, this is a great question. Number 90, how do you get to the asymptotes without graphing? Now, excuse me, we agree that you know where the center is, right? Okay. We know that the center, the h and k, is at -4 and 9. You also agree that your a squared value is, since the larger value, the x squared comes first, it's going to be left-right. Okay. So you know it's got to be left-right from what it looks like. So your a squared is 225. Your b squared is 36. That gives you your distances from center to vertex, center to co-vertex. Now, from this point, I know that my a value would be plus or minus 15, b is plus or minus 6. In lieu of totally graphing, if you understand what direction it's going, knowing that your center is here, that means your vertex has to go right, and then it's got to go up, doesn't it? So I'm going to add 15 to this and add 6 to that. So I'm going to get 11 and 15 as that point there. And then I would add it and subtract it to get that point there. So I'll have 11 and subtract 6 and 3. So now I have 2 ordered pairs. And I can write the equations. Does that make sense? You can probably, sometimes if you know that you went up 6, right 15, up 6, right 15, there's your slope. Where we're going? It's a great question. How can you write the equation of an asymptote without graphing? And that comes from knowing what A's and B's do and what that box means. Yes, ma'am. The foci for this one? Hi, Mr. Fontana.
Did you run pre-calc yet?
I did not, because you said,
How many do you need?
30, maybe 35, just in case I misspell something. You're the best. Focus on this one. How do you identify how do you get the C value for a hyperbola? Very good, you add them. It's a squared plus b squared gives you c squared. So 225 and 36.
261.
What is it?
261.
So the c value is the square root of 261. Now you agreed that the hyperbola is going left and right, correct? To what value of the center do I have to add the square root of 261 to? The x or the y? The x, that is moving left and right. The y value stayed the same, so I know that my ordered pair is going to be -4 plus root 261, comma 9, -4 minus square root of 261, comma 9. Which one? 11 and 15, 11. What that is, this point is when you're creating the hyperbola, when you have your center, your vertex, since it's going this way and this way, your A value is here and here. Your B value was here and here. So you were able to create this rectangular box that your slant asymptotes went through. What we were doing is we realized that our center was here. We went up 6, right 15. There's my slope, B over A. And then the opposite of B over A is the other point to get the negative slope. So I had two ordered pairs with the slope. I could use, what was it? 6 over 15 is what? 2/5. So y minus 9 equals 2/5. X plus 4. Y minus 9 equals -2/5. X plus 4. That's how to write those equations for the asymptotes. Another thing is, if you forget how to write the equation of the asymptote, but you remember how to find that point here and here, which really isn't terrible, I hope. If you were given a list of equations of asymptotes, all you would have to do is substitute in these 2 points, and if it's a true statement, you know it's right. You can always fall back on the plug and chug. Okay. What do you got?
16.
Half of b and squared. So what's half of 11 over 9? 11 over 18. Square it. 121 over 1 number 324. You take half of b and you square it. In this case, it's a fraction, so you take 11 ninths times 1/2, you get 11 18ths. Square it. 121, 324. And that's what you would add. Yes, ma'am. That was a very polite eye roll. GCFs. 5, x minus 10, -1. Then I get x plus 14, or x minus 14, x plus 40. That'll give me minus 10 minus 4. When you have that leading term that's negative,
Negative.
yeah,
Negative x minus 7. Then you gotta carry negative. No, on the denominator.
doesn't matter where it goes in a fraction.
Yeah, that makes me feel better.
It doesn't have to be. Remember, the negative can go either way.
Right under the denominator, what is the x squared?
Yeah, what I did is, I just shorthanded it real quick. Whenever I'm factoring something, I want that leading term coefficient to be positive. So I just took out the -1 and went from there.
All that?
It's a hyperbola. So we have vertices at 1 and 21 and 1 and -5. So if my vertices are at 1 and 21 and 1 and -5, what direction is the hyperbola going? Up and down. If it's an up and down hyperbola, what comes first, the x minus h or the y minus h? Well, let's take a look. Take a look at you. Means I'm looking at that one. So I know that. What occurs halfway between the vertices?
Center.
Center. What's what's positive 21 plus -5? 16. 21 minus 5. 16. What's half of 16? 8. So my center is at 1 and 8. So there's my h and k. How far apart is 8 from 21? 13. So my a value is 13. So a squared is 169. Our c value, they gave us the distance from the center to the focus is the square root of 269. So what's c squared? 269. To get b squared, what do you? 100. Very good. And now you have everything. The trick is to identify the center, and then remember that your center vertex is A, and it peels out everything. See how it's stacked vertically? You have two vertices are above one another. That means it's got to be stacked that way. Same thing same thing with an ellipse. If the ellipse were above one another, it means it was stretched vertically. If they're across from one another, I guess this is still across, but if they're
Alright, that.
So as long as you know which way it's going, you can like just.
rapid fire. No. What do you got?
Y is 8.
Find it quick.
H and
Excuse me. So this is 8 to the 4/3, n to the 9th to the 4/3. 8 to the 4/3 means what's the cube root of 8 to the 4th, which is power to power you multiply. 3 times 4/3 is,
what is that number? Is that 12?
Yeah,
I'm sorry, 9 times 4/3, excuse me.
Is it 12?
Is
Yeah,
that-
it's 12.
That's a ugly 12.
Okay. And the next one here, what's the square root of 81?
Square.
9, and what's 6 times a half?
9.
So 9x cubed.
Sweet.
As your life coach, I'm really happy to help. So if I'm the life coach, what would that call you? You're the life participant?
Student of life.
Student of life.
The life trainee.
Life athlete.
The life lead.
The life lead.
You're the life lead. What number was it? I forgot. I have short.
48.
Look at that.
I should remember.
Oh, the inverse. You're so much fun. So when I go to do the inverse of this one, this is one of those examples that you want to float that negative symbol to the 3 in the numerator. So then I'll do the exchange-o, x equals negative 3, y minus 2 minus 3. Add 3. And now exchange-o on your diagonal. And then add 2.
You just flip it.
What?
You just flip them. You just
Wait,
flip
wait,
them?
wait, what? That's why I was
Hold
stuck
on.
on the
X plus 3 times
Stop the clock.
Distribute it to both parts.
Where did that one number go?
Hold on. You can just flip them.
What are you flipping?
You can take the X plus 3 and the Y minus 2, just flip them around.
Well, remember, and I did this one earlier, to get rid of this, you'd multiply by y minus 2. Do you agree?
Yeah.
So these 2 go away. You okay with that?
Yeah.
To move this, I divide by x plus 3.
So
Those 2 go
technically
away.
You can
So you tell me you just
And then
flip
you just add the 2.
Right.
Can you flip them?
Can you do it for
You-
everything?
Reverse everything?
Fraction equal fraction, you are, in essence, you have what's called a
Why did I do this
portion.
when I was taking this test?
When you have proportions, you're able to take,
I did all that.
well, for example, 4 over 8 is the same thing as 3 over 6. Do you agree?
Yes.
They both simplify to a half.
Yes.
If I exchange them on the diagonal, I get 6 over 8 and 3 over 4. Is that true or false?
True.
It's true. If I exchange them going the other way, I get 6 over 3, which is 8 over 4. Is that true?
Yes, that is.
Good. If I go back again, that means I get 4 over 3, which is 8 over 6, which is true. Anytime you exchange things on a diagonal, you have a proportion, it works. It's a nice little thing. Kind of a big thing.
Made my life a lot easier.
She does it for everything.
I need more coffee.
She wouldn't take it in class.
Very sad.
Really doesn't take it serious.
You should be curious. I'll do it back.
Trust me, I thought about it, but then that get expensive. Yes, ma'am.
You charge your students.
You need a big service.
That's a decent size.
No, like a big one.
Nah,
Leader.
80.
What? Service. Big one. No, we should.
See, what's nice about this is that you're going to have a y equals x squared forever. If you move stuff around, you're going to get y equals x squared minus 10x plus 22. Couldn't I go from there to figure out at least my center, where it's located at? Now, it also has the idea of writing it into that standard form. So depending upon what choices you have, you could probably find your center here with the calculator without so much of a hassle. Now, if you wanted to get into that 4p format, that's when we have an x squared parabola, so it's going to be x minus h quantity squared equals 4p y minus k, according to my little conic thing. Now, if I go back to the original style, we had x squared plus 10x, I know it's negative, plus y minus 22 is 0. What I'm going to do is send the x squared and the 10x to one side and keep the y minus 2 on the other. Okay? So I'm going to get basically this in reverse. I'm going to put the x squared on the right. Okay? I was going to try and, look, I'm going to write my x sideways, backwards. Okay. So I do the complete square. What's half of negative 10? Square it. So we get y plus 3. And I get that. Now it does mirror this, but now what's my value of p?
0.
If it was 0, it would not work.
1/4.
1/4. What? Because what's out in front of it to make it not have a value. Does that see where I'm going with that?
So 1 equals 4. 1 equals 4.
Yes. 1 would equal to 4p, p equals to 4, right. So I have center then at 5, -3. And then my focus, since it's an x squared one, my focus would be above it. And so I'd add to the y value, my p value, which was what? 4. Positive 1. Because when you're at this point here, and you have y plus 3, what's in front of this? So you set that 1 equal to 4p, so your p value is a 4. That's a little trick on that one. Yeah. Ken, what were you going to say? Get rid of the fractions. What do you multiply everything by? 2n squared. This one has that, so it's 2 plus 2 times 2n minus 4 equals 1. Minus 2. Well, I think so.
How did you get that? 2 plus 2 plus 2n.
First fraction needed a 2, so I multiplied it by 2. Second fraction needed a 2, so I multiplied it by 2. Last one didn't need anything.
Wait.
Okay.
Rapid fire. Ah, there's a shortcut involved with this. Let's say you forget, no, it's not a matrix one, it's your square terms. Let's say intersection, if you have an intersection of 2 lines, some point would be a true statement for both of them, both equations, right? You can plug and chug. Or think about when you had elimination and stuff back in the day. If I wanted to isolate a variable, notice I have same coefficients with same signs there, don't I? Subtract the 2 equations together. When you subtract the 2 equations together, you're going to get x squared plus 7x is 0. That'll give you your 2 possible values of x. At 0 and -7. Therefore, it generates possible values of y. Fast. So I know it's not going to be just C, and I know it's not going to be D, and I actually know it's not going to be A because 4 wasn't one of the zeros. Therefore, by process of elimination, I use elimination.
I was just nice check.
That's what I'm here for.
Maybe
It's got it.
nice pattern.
Same thing with 99. Do the same thing. I think on 99 you add them together.
Can you do 99 then?
I subtract the equation together.
Can you do it for all?
Yeah. Do the same thing. 99, same thing, guys. It's just by looking at the values here. If you look at these, you're going to have to see how I have positive y squared, negative y squared, positive 12y, negative 12y? I can eliminate the y's by adding. Add everything together. 24 x squared, 96x, minus 120. GCF, 6. It's 5, right? Yeah.
I think
Or
it's
is this
4.
a minus?
We're at 6.
Thank you. I was wondering why it wasn't working. I'm like, wait, what did I mess up? So it'd be x plus 5, x minus 1. So you have possible x values at negative 5 and 1. And then looking back at the solutions, the only one that has a negative 5 as a possible x solution again is you don't even have to go back and substitute in. One second, we'll write it out. That's awesome. Wait a second. Wait, what's that?
Did you do like 46 or
Wait, what was the answer?
B, I believe. 77?
46?
The complex fraction. This one should be pretty simple because the bottom part already has the common denominator. So you wind up with x plus 2 divided by 2 divided by x squared plus 1 over x plus 2. Flip it. And absolutely nothing's going to simplify out. So you're going to get, I think the answer would be the quantity x plus 2 squared over 2 x squared plus 1. And that would be your final solution. You can't do this.
Oh, you just.
I asked for the easy ones because I forget how to do the easy ones.
Alright.
Which one was it?
46.
36 or 26?
46
40.
or 47. Same thing. Just forgot how to do it. It's like a 10. Do I do 10? So I just times like, you just times the two together? You don't
You're
have to do
just
the whole thing.
substituting it.
Okay. You don't have to do it then.
Yeah, you just substitute 10 in for G, and then 10 in for F, then multiply that by 4 and then subtract it. It's order of ops problem is really all it is. No. First rule of that is you gotta go to the factor out there. You gotta get your GCF.
So you factor out the 3x?
Yeah, watch.
So like, wait, actually, I need you to do it. So for G, put 10. And for X, you put
So you factor out the 3x here, you're gonna get 2x plus 1. So that's gonna be the denominator.
Okay, alright, and then, okay, so, and then like for the, when you, I think it's 4 times 2x is 5. What would you?
You don't, the second factor doesn't need anything. No, because the common would be 3x and 2x plus 1. Since this one already has all of it, you just gotta subtract 2x, subtract 5, because you gotta distribute to those parts. That's what we'll get.
And then the first one would just be,
2x plus 4 times.
so 40.
Yeah.
alright. Alright.
40. You show me this.
I did that one the other day. Yeah, do this in the square on that.
7. Is that the answer?
You gotta regroup.
Oh, that was
You gotta take out your 4, and then you gotta go to the big square process. And go from there. It's either gonna wind up as a, since you go up the finger, it's either gonna wind up as a circle or an ellipse, just depending on what you wind up with.
I want to see it. Or my glasses here. I mean, I've seen it before.
I'm already out of them. There might be some in the cabinet there on the top, second from top. Go, yeah.